Happy Tuesday. Quick video here for you today. Today we're going to be talking about the second part of sequences, and that is series. Okay? And so we're going to talk a little bit about series and the difference between a sequence, which is very similar, but there's one key difference. Okay? So a series is when you take all of the terms and you add them together. So yesterday, this would have been our, 2, 4, 6, 8 would have been a sequence. Yeah. But now, today, a series is we take all of those terms and we add them together. And that's the only difference. We're taking all the terms in a series and you add them together. Okay? There are two different types of series. There's finite series that end, it's 10 terms, it's 15 terms, but there's a set number of terms. And then there's infinite series, which the pattern would continue on forever, and it's impossible to find the sum of an infinite series because the terms go on forever and ever and ever. Okay? So, and then on top of that, when we get into next week with geometric sequences and series, those we can find sums of infinite ones because the numbers get so small that we're really not adding anything. But when we're adding us, like in this case, we were adding 2, we're adding 2 every single time. That number is always going to keep going, and so you can't find the sum of an infinite series. Okay. Summation notation is the other part of this particular, when we're talking about series. And summation notation is also referred to as sigma notation. Okay? And summation notation, along with sigma notation, same thing, uses the Greek letter sigma, okay, which is that funky looking E. Okay? And it's very easy to figure out sigma notation. Okay? So you're going to have that funky looking E. Okay? And then you're going to have some variable. And I don't care what your variable you choose. You got 26 different choices. Commonly, they use I. Sometimes they use X. Sometimes they use K. Okay? It doesn't matter what you use. Okay? But that variable is going to have some starting value. So it's going to start at like 1 or 0 or 5. Okay? It's going to have some starting value. It's going to have an ending value. And then there's going to be some rule out here. Some expression, if you will. Okay? And how you find the values of that sequence or that series is you take the starting value and you plug it into the rule. And that's going to give you out a number. Then you take the next whole number, the next integer, plus 1, if you will, and you plug that one into the rule, and you get out that term. And you keep repeating that process, plugging in the next integer until you reach the ending value, and then you stop. Okay? Now, for an infinite series, okay, this ending, it can also be infinity. And that would just say that you would keep following that pattern forever and ever and ever. It would never stop. Okay? So the big difference from yesterday to today is now instead of having commas in between our terms, we have addition signs in between our terms. Okay? So write the series using sigma notation. Okay? Well, we first got to figure out, oops, I should go this way. So we first have, so if I'm using sigma notation, I'm going to start with my big E, my big sigma, if you will. Okay? And so then we have to figure out what variable we want to use. I really don't care what variable you use to choose. I'm going to use x as my variable. So x equals that. Okay? Now, commonly, okay, biggest mistake is when we go back here and we look and we say, okay, 25 is the first term, people want to put 25 right there. And that's fine if you can come up with a rule that would fit that all the way through. But it's easier, usually easier, if that is 1, signifying your first term. So down here, we would say that x starts at 1. Okay? So x is starting at 1. Then, if that's my first term, and it looks like I'm going up by 25 every time, I can say that my rule is 25x. Okay? Because the second term would be 2 times 25, third term would be 3 times 25, and so on and so forth. If I follow that all the way through, then 250 would be, oops, excuse me, not 250 equals 250. Then 250 would equal 25x, and x would be 10. So 250 is the 10th term, so that would be my stopping value. I start by plugging 1 into my rule, 25x, 1 times 25 is 25. Then 2 times 25 is 50. The second term, 3 times 25 is 75. The third term, fourth term would be 100. Fifth term would be 125. And so on and so forth until I get to my 10th term, and my 10th term is 250, and that's where I end. Oh, let's use y this time here. Okay? So that's a good spot to start because that's what our answer is going to look like. Okay? This over here, this would have been the answer, the sigma notation, the summation notation for that particular series. Okay? So here's what it starts. I've got my sigma, I've got my variable. Okay? I'm going to start at 1 because this is going to be my first term. If that's my first term, okay, and then I'm kind of looking for a pattern here, well, that pattern would be y, because it goes 1, 2, 3, 4 on top, 1, 2, 3, 4 on top, so that's y over y plus 1, because the bottom is 2, 3, 4, 5, and that pattern would continue. Now these dots right here at the end of this, those dots right there signify that that pattern's going to go on forever and ever and ever and ever. Okay? So that to me says we're going to infinity. And that would be the summation notation for that. Okay? Good way to check, your rule has to work for every term that you see. If your rule only works on one of the terms that you see, then it's not a rule for that sequence or series. It's got to work for every single term that you see. Going the other way, finding the actual sum, well, for right now, because we don't have any formulas yet, for right now what we've got to do is we've got to find the terms of our series. So my first term, I'm going to take 1 and I'm going to plug it into my rule. So 1 times 8 is going to be 8. Then I take my next number. So that would be my second term. That would be 8 times 2. 8 times 2 is 16. Third term. Fourth term. Fifth term. And that's where I'm going to stop because it said stop when you plug in 5. Okay, so I plugged in 1, 2, 3, 4, 5. I got 8, 16, 24, 32, and 40. So to find the sum of those, I add all of those 5 green numbers together. 8 plus 16 is 24. 24 plus 24 is 48. 48 plus 32 is 80. 80 plus 40 is 120. So the sum of this series is 120. Same concept over here. I find my first term by plugging in. Now I'm going to plug in 3 into my rule. So that's going to be 3 squared minus 1. 3 squared minus 1 is 8. Then I find my next term, my second term. I'm going to plug in 4. 4 squared minus 1 is 16 minus 1. That's 15. Third term, 5 squared minus 1. That's going to be 24. Fourth term, 6 squared minus 1 is going to be 35. Fifth term, oops, that's a bad 5. Fifth term is going to be 7 squared minus 1. That's going to be 48. And that's where I'm going to stop because I reached my 7 that I'm plugging in into my number. Over here, it was, the 5 was right there. That's why we stopped there. Again, then to find the sum, I add them together. 8 plus 15 is 23. Plus 24 is 47. 47 plus 35. 2, carry the 1, that's 82. 82 plus 48 is 0, carry the 1, 130 for this one. And that is your introduction to series. Thank you for playing along today. We'll see you in class tomorrow where we'll dive more into the concept of an arithmetic sequencing series.